Good evening, everyone. Welcome to the lecture series on misconceptions in physics. My name is Ratankar Rao. I teach physics in an international school. And the series that you are looking here, we have reached 105th video, I suppose. Just a moment. Let me find out. Yes. So it's the 105th video on misconceptions in physics, the video series. So this series is not aimed at teaching students for JE coaching or IBDP or whatever it is. So it's not aimed at a given course, but it is something like solving problems wherein a given concept which has been misused or which has not been used appropriately in a given context. And this way, these videos might find a way to. Okay, let me share my screen. You can access all my videos from my website. The name of the website is already given. Just a moment. Right. Okay. Right. So this is the name of the website, which is ratankar.com in my same name. And I also given you my contact number. You can contact me through WhatsApp. You can send whichever video, whichever problem you have, which you have not understood. But what I would like to take is you can send me the problem, but just the problem will not be sufficient. You need to give me even the solution that you had attempted. Maybe it could be an incorrect one, so that I can take it across and then give you the correct one. So basically, my videos are being structured into three parts. The first part is about understanding about the problem. 70% of the problem solving techniques lies in understanding the problem. So one of the examples which I'll be showing you in this, students usually misunderstand the problem, think, assume, and then say, okay, maybe this could be the problem. There's the first mistake people do it. So I would like to explain it into detail here. And the second part is understanding the student response. Usually, a student misunderstands the problem, doesn't understand the context, and he understands the concept very clearly. Okay, so it's something like, let us say, F equal to MA, everyone knows, but where to apply, how to apply is a bigger question. So even if you teach them 100 times, you see they would make a mistake in this particular concept. So therefore, the context is very, very important. So I describe what is the solution which a student gives, and then where he has made a mistake and why or where should he actually apply that particular concept. That's also been described. And the last part is giving the correct solution. So this is how my video has been structured. And today we'll be looking at the frictional force calculation. If you want to see about all my other videos, you can visit this particular website, ratankar.com, where all the videos are being present. So usually my videos will get broadcasted in YouTube at 7 p.m. sharp. Today also one video has been broadcasted. This is some of the extra lectures which I'm doing it, scheduling for the next few days. And by 8:30 or maybe at 9:30 p.m., the same video will exist. The link would be shown in LinkedIn or maybe Facebook, Twitter, Reddit, okay, and all other social media. And maybe by 10:30 p.m., you can see the same video in my website also. So this is how the structure actually goes with. Okay, enough of my introduction, my website. Now let me start with the video, with the problem. Now towards it, the first thing is that frictional force calculation in a vertically sliding object. So you have an object of mass 3 kg, it is seen to be sliding. Let me read the problem. A force of 100 Newton is applied on a block of mass 3 kg. I'm going to apply a force over here. The coefficient of friction between the surface and the block is 1/4. The value of mu is given, value of the mass is given, then the frictional force acting on the block is. The moment a student reads this and he sees this picture, he says, assuming the block is stationary. This is the biggest misconception you have. Okay, so you should not assume anything. Of course, if we say in physics, we need to assume. But based on what is being given, you should assume the context. Now, what is that you happened? You have identified the parameters correctly, but unfortunately, you assumed the context is a different one. And as a result of it, you say the downward force is equal to upward frictional force, which means what? The downward force here is nothing but 3 into 10 m into g, which is 30 Newton. Now, if this has to be stationary, then there should be a frictional force acting here. Then the question I should ask is, why did I give this one? If I'm not using this, there's no point in giving this one, right? So somewhere you should reason it in a logical way. Do not assume things just because an simulation is, sorry, a figure is being given to you, an image is being given to you. Do not assume anything there. Now let us try, okay, how to solve this problem. Now, as usual, this is the normal, this is the force that has been applied. The component of this force is acting here. What is the component of this force? The component of this force is nothing but 100 cos 30. Let me draw the free body diagram. So you have the object. Here you are applying a force of 100 cos 30. This is my, what do you call? This is my surface. Friction is here. mg is acting downwards. What is the mg value? 30 Newton is acting here. Okay. Now, there should be a frictional force acting here. That's what we need to know. Now, if I am applying a force of 100 cos 30 here, then there should be this object should be compressed, right? Why is it not getting compressed? Because this force is acted upon on this wall, and this wall now gives an opposite reactional force. What is this reaction force called as? See, this is a surface force. What you call it as a normal reaction. Now, can we write, because it's not going inwards, not coming outwards, can we write n is equal to 100 cos 30? Definitely we can do it, right? N equal to 100 cos 30. So the normal force is given. Now, how do you write frictional force? Frictional force is nothing but equal to, how do you write this? It should be mu times n. What is mu? 1 by 4. What is n? 100 cos 30. So thus your answer should be 25 cos 30. So this should be 25 into root 3 by divided by 2, which should now be equal to 12.5 root 3 unit Newton. So thus you see, we have got a net answer here, which is not equal to 30 Newtons. Okay. So this is how you need to solve this problem. Now, where was the misconception? Misconception was in the assumption here, assuming it is stationary. Now, can you tell me whether the object is moving up, down, anything is happening here? Let us work it out. The question has not been asked, but anyway, let us work it out also here. So towards it, we might get a wrong answer also. You need to find out why we are getting a wrong answer, because some parameters I have given on my own. Okay, because student did not supply a appropriate problem. So I have put across the values over there. Now, what is this 12.5 multiplied by root 3? Let us calculate this value. This value is, just a moment, 12.5 multiplied by root 3. What is root 3? 1.732. 1.732. I get the answer is 21.65 Newton. 21.65 Newton. Now, if this is 21.65 Newton, what is the downward force? 30 Newton. So you have the object, 30 Newton is acting here, 21.65 Newton is acting upwards. Do you think the object will come down? Still, we don't have an answer here. Let me tell you, we are missing something here. I think many of you would have guessed by now. I have taken only the vertical component here. Hey, what about the horizontal component? This is a force. This force I can also consider here also, right? Horizontal component here is nothing but 100 sine 30. Okay, I missed this. So let me apply here that there is a force which is acting in this direction, which is 100 sine 30, which aids your frictional force, which would be 100 into half, which is equal to 50 Newton. Okay, so therefore, now what is the total force acting upwards? Law of vectors, addition of vectors. So one force is nothing but frictional force, which is 21.65 Newton. The other force, since I have applied here, is nothing but, what is this force? 50 Newton. And then the object is here. This is 30 Newton. Now 21.65 plus 50 is going to be 71.65 Newton, and which is acting upwards. And the 30 Newton is acting downwards. Now what will happen? Which force is larger? This force is larger. So what should happen? The particle should try to move upwards, right? Is this correct? No, there's one more mistake here. Okay, let me tell you what is the mistake over here. So you should not arrive or jump down to conclusion. Now you can always ask me, hey, friction is a force which opposes the relative motion. If 50 Newton is acting here and 30 Newton is acting here, You should expect the object to go like this, right? 50 plus 50 minus 30, which should be 20 Newton. The net force acting on the object should have been 20 Newton upwards. Okay. Now, what should be the frictional force? Frictional force is nothing but mu times n. Mu times n. What is this mu times n? Mu times n is nothing but, how much did we get? 21.65. Now, if the object is supposed to move like this, larger force applied over here, the static frictional force should be 21.65 Newton, which means the object is assumed to be at rest. Okay, because if at all, if this becomes 21.65 Newton, only then the object will move. If the net force is larger than the frictional force, it will move, right? Okay, otherwise the object will stay at rest. So as a result of it, before answering this question, what we need to ask is, arrive at the FBD and then ask whether the object is moving or not. If the object is moving, then this method is correct. If the object is not moving, now your answer should have been 20 Newton only. Why 20 Newton? Because if frictional force is larger than this applied force, the object will come down. Do we ever see a situation where the frictional force is larger than the applied force? You will never find out. Okay. Frictional force can either be equal to the applied force or less than the applied force. If it is less than the applied force, then the object moves in the direction of the force. If it is equal to the applied force, the object is stationary. But there's something called as a static friction. What is static friction? When you apply a force and it is lesser than the static frictional force, then the friction self-adjusts itself. Now here, friction is a self-adjusting force. Now you see, so much information is hidden over here. So one should do it very carefully. Okay. So therefore, if the object was moving, then definitely this is your answer. Now for this problem, okay, the correct answer is seen to be frictional force is equal to 20 Newton only. Okay. The first thing what you need to do is, you should ask what is the net force acting on the object. I hope you understood this particular problem. If you do not, then might be I will take up once again the same problem and then describe you, okay, like how does it work. Maybe I can put 2 more slides and then describe it across. Thank you, friends, for watching this video until the end. If you do not watch it until the end, you may not get the glimpse of it. Okay, do watch it and do like, share, and subscribe to my channel for more such updates. This will really help you in attempting any of your examinations. Thank you.